In this video, you can practice conceptual subtraction. First, thinking about place value, and then thinking about the traditional procedures, but also thinking about the meaning and the value of each number. Of course, this work should only come after students have worked with manipulatives and pictures to actually see what subtraction looks like. For many students, subtraction is difficult, and we need to start slowly and build that meaning through real contact with objects and visuals. Practice these three problems using place value subtraction, that is, thinking about ones, tens, hundreds, etc. Then pause the video and see if your thinking matches my explanation. Here's the actual meaning of these problems and the kind of thinking we want students to do. Looking at the first problem, we have 3 tens take away 1 10, and we have 6 ones take away 2 ones. Now we can go back and say, which of those can we do without any problems, without any regrouping? 3 tens take away 1 10 is 2 tens. 6 ones take away 2 ones is 4 ones. If we put them back together, that means our answer is 24. In the next problem, we have 3 hundreds take away 100. We have 1 10 take away 8 tens. And we have no ones take away 9 ones. Now we have our problem divided into its place value components. Which of these can we already do? 3 hundreds take away 100 is 2 hundreds. We can't take 8 tens away from 1 10. We need to get some more tens. So where are we going to get these tens? We're going to take 100 away from this, and we're going to break that 100 into 10 tens. Now we already have 1 10 here. So we don't have 1 10 anymore, we have 11 because we had 10 and the one that was already there. 11 tens take away 8 tens is 3 tens. Now we have 0 ones take away 9 ones. We can't take 9 away from 0, so we're going to go over to the tens, we're going to take one of these tens, and we're going to break it into ones. That 10 now gives us 10 ones take away 9 ones, which is 1. So if we put our number back together, we have 100, 2 tens, and 1 1. Our answer is 121. If we look at our third problem, we have 5 hundreds take away no hundreds. We have no tens take away 4 tens. And we have no ones take away 3 ones. If we break our problem apart, that's what we have. Which of these can we already do? Well, this is a little bit tricky. We can do 5 hundreds take away no hundreds, but we're still going to end up with 5 hundreds. We're going to need to take one of those hundreds to give to the tens. So if we take that 100 that we took from here, that would give us 10 tens. So now we have 10 tens take away 4 tens, which is 6 tens. But we still have no ones take away 3 ones. So we'll take one of those tens, now we have 5 tens, and we'll make that 10 into ones, so now we have 10 ones. 10 ones take away 3 is 7. So what do we have left? We have 4 hundreds, we have 5 tens, and we have 7 ones. So our answer is 457. Did you notice in all three of these problems that even though technically we did have to do some trading, the trading was much more logical? It wasn't a question of where do we cross out and where do we give and where do we put the number. It was all very logical. Break the 100 into 10 tens. Now we have enough. The other logical part of this is always doing what you can do. We're not just starting from the right and going to the left. We're doing what can be done, and then when something can't be done, we logically think about how we fix it. This is conceptual subtraction. The only disadvantage to this kind of subtraction for students is that it's a lot of writing, but for many students it helps them understand, especially when they have to regroup. How did you do? When we move from that kind of place value conceptual understanding to procedures, we want students to still think with that kind of language. Do these three problems and do them out loud. What kind of language will you use as you complete the problem to show that you understand the value of each number? Pause the video at this point and complete these 3 problems in the way you were taught traditionally. Then restart the video and let's see if your thinking matches my thinking. Looking at the first problem and thinking about traditional subtraction, we would start with the right. We would say 6 ones take away 2 ones is 4 ones. 3 tens take away 1 10 is 2 tens. My answer is 24. In the next problem, we have no ones take away 9 ones. We can't do that, so we're going to go to this 10. We're going to take that 10, which means I have no 10s left. We're going to break the 10 into 10 ones. Now I can subtract. 10 ones take away 9 ones is 1 1. But now I have 0 tens and I need to take away 8. I need to get some tens. So I'm going to take one of these hundreds, which means I'm only going to have 2 hundreds left, and I'm going to break that 100 into 10 tens. 10 tens take away 8 tens is 2 tens. 2 hundreds take away 100 is 100, so my answer is 121. In this problem, I have 0 ones take away 3, which I can't do. So I go to the tens place to get a 10 that I can break into ones. But there are no tens either. So that means I'm going to go to the hundreds place, and I'm going to break that 100 that I take from the 5 into 10 tens. So now I have 4 hundreds because I took one. I broke it into 10 tens. But I still don't have any ones, so I'm going to take one of those tens, and I'm going to break it into 10 ones. Now I have 10 ones take away 3 ones, which is 7. 9 tens take away 4 tens, which is 5. 4 hundreds take away no hundreds, which is still 4. And my answer is 457. When students do traditional subtraction, we still want them to think about the value of the number. This 8 is not an 8, it's 8 tens. This 4 is 4 tens. This 3 is 3 tens. This 3 is 3 hundredths. If students don't think about the value of a number, then 1 3 can seem like any other 3. But thinking about the value of the number really helps them understand subtraction, and it especially helps them decide when they have to trade or regroup. And that's very important.